Now here, open your box on page 47. We're going to answer this lesson for the air resistance and drag. As we talked yesterday, air resistance is a force that slows down moving or falling object. Drag is another name for air resistance. In this exercise, you will think about air resistance and parachutes. In this drawing, it's showing two people jumping with a parachute. This is number A and number 1. Okay, so first question, which parachute will fall faster? We have this person with a bigger parachute and this person with a smaller parachute. Now remember, yesterday we said that air resistance is affected by the surface area, which is the area that is subjected with the air, the area that's going to be hit by the air or the wind. So here we have this one is bigger, so it's going to hit more air, which means it's going to be slowed down more. This one is smaller, which means less air resistance, which means falling faster. So which one is going to fall faster? It's number 1. Now explain why. I explained it. The answer is because he has less surface area, which means less air resistance. Okay? Now question 2. Label the forces acting on the parachutes and show the direction in which each force acts. This is going to be your homework. Okay? You're going to draw labels here by showing arrows on what are the forces acting on each one of them. Now there are two forces, the gravity, the first one, and the air resistance. You have to show me the direction of each one of them and you have to write the labels, okay? Question 3. Do you think parachutes fall faster or slower if the person or weight is heavier? How can you test this idea? Do you think the parachute fall faster or slower and the person or weight is heavier? Now you might think that yes, the weight makes a difference, but the answer is no. It won't fall faster. Why? We said yesterday that what affects air resistance is surface and speed. The weight does not affect air resistance, okay? It won't fall faster or slower, it's going to fall the same. So the answer no, it won't fall faster or slower. How can we test the idea? I'll send you a video explaining this, but when we bring two things of different weight, let's say two different balls, and they're the same surface area but different weight, and we drop them from the same distance, from the same height, they're going to fall exactly the same. Why is that? Because they have the same surface area. Let me show you here. We have this ball, this one ball, and this one ball. They're the same size, same surface area. Here, same surface area and same surface area here. But this weighs 1 kilogram and this 3 kilograms. Now, when we drop them from the same distance, here is the ground. When we drop them from the same distance, gravity is pulling them down, and air resistance is pulling them up, keeping them up here. Air resistance is hitting this surface, and here it's hitting the same surface. so it's not going to slow them down the same way. So they're going to fall down in the same speed, okay? Because it's hitting the same surface. Now here in this page we have a rocket. This is a rocket, okay? Now when these rockets are launched into the space to escape the Earth's gravity, they use a force called thrust. This force right here, it's from engines. Now we know that this is the engine, okay? It gives a big force, a strong force to move it up against the Earth's gravity, okay? So here we have the first question. Label the forces acting on the rocket in the drawing. So here we have this force, which is moving it up, and here we have this. So we have three forces acting on this rocket. The first one is gravity. Gravity is strong and it's pulling it down. So here we have gravity. The second one is air resistance. Air resistance is also trying to pull it down here. Why is air resistance is moving down? Because this shuttle is moving up. It's moving this direction. It's leaving the earth, leaving the ground. It's moving up. Air resistance is always in the opposite direction of the movement. Okay? Remember, it's always in the opposite direction of the movement. So when this rock is going up, the air resistance is trying to push it down. But we have the strongest force, which is the force of the engine. We said its name is thrust. Okay? Thrust is stronger than gravity and it's stronger than air resistance. That's why it can move up. Good? Now here, in the question, number 1, we answered it. This is the answer. Label the forces acting on the rocket in the drawing. We have air resistance, which is a small force pushing it down. Gravity, pushing it down because it's moving up. And we have the thrust from the engines, which is moving very fast and it's very strong. It helps the shuttle and the rock moves up. Okay? Now question number B. Which force pushes the rocket upward? And which force pulls the rocket towards the earth? Also, this and this are homework. You're going to have to answer them too. Now here, when the rocket moves upward, are the forces balanced or not? Explain your answer. Now when we talked about forces in the past, remember we said that balanced forces, they do not make objects move. But the rocket moved. So are they balanced or not? Take a moment to think about it. The answer is no. The forces are not balanced. Why? Because thrust is larger than gravity, and air resistance, and that's how the rocket moved.